Hey guys, this is Saurav here and welcome to another session for the KVPY SX section, and this is the lecture that's for grade 12th, and this lecture is on atomic structure, chemical bonding and periodic properties. This we are doing an immensely amazing session for KVPY. Please do tell your friends. And atomic structure, chemical bonding and periodic properties are like very I would say like not so very focused area of KVPY examination, because the questions that come are very infrequent. बहुत कम questions आते हैं and बहुत easy questions आते हैं. Okay, you will see that the previous year's questions जो हमारे पास present हैं, they are like really easy. Okay, so if you are getting a question from atomic structure, chemical bonding and periodic properties, you should be very happy. Okay, so starting off the session with this message that please do follow the schedule. We are at atomic structure, chemical bonding and periodic property. The next session would be on GOC and chemical and physical properties of organic compounds. Please do join us for that session, because GOC से questions काफी अच्छे amount में आते हैं. Organic chemistry takes up a huge chunk of KVPY questions that come in the SX section. Okay. Also, please do tell your friends about the Telegram group. Please do join the Telegram group, because a lot of amazing things are happening over there. You can discuss your questions, you can like post your doubts, get them resolved. Also, like, share and subscribe the channel so that the word reaches out to as many number of people as possible. Okay, with this, let's start today's session with the first question. The first question is this. The first question is the energy of a photon of wavelength 1 meter, Planck's constant is given, speed of light is given. We have to calculate the energy of photon. बहुत simple सा question है, हमें मालूम है कि क्या equation use करना है. We need to use this equation. E equals to hc upon lambda. Absolutely no confusion over here. H की value दी गई है. Planck's constant is h, 6.626 times 10 raised to minus 34 times 3 times 10 raised to minus 8 upon 1 meter. Okay, so ये value कितनी हो जाएगी? 10 raised to this will turn out to be somewhere about 19.8. so मैंने 6.626 को approximate कर दिया. 6.6 times 3 is 19.8 times 10 raised to minus 26, which will give me an answer 1.98 times 10 raised to minus 25. The right answer should be D. ओके, क्वेश्चन को सॉल्व करने में मुझे ही इतना कम समय लग रहा है. यू विल टेक ऑलमोस्ट मच लेसर टाइम. टीचर से स्टूडेंट्स ज्यादा शार्प होते हैं. ठीक है, नेक्स्ट क्वेश्चन. द एनर्जी द इलेक्ट्रॉन एंड हाइड्रोजन एटम इज इन द फर्स्ट बोर ऑर्बिट एंड द विच इज n equals to 1. फर्स्ट बोर ऑर्बिट के लिए हम बोलते हैं n equals to 1. प्रिंसिपल क्वांटम नंबर इज गिवन एज n equals to 1. The ratio of transition energies from n equals to 1 to n equals to 3, first energy level to third energy level, and from n equals to 1 to n equals to 2, first energy level to second energy level. Now it is important to know that energy levels जो हमने n equals to 3, n equals to 1 लिखा है, इसको हम लोग first excited state, second excited state ये words भी use करते हैं. And what is the meaning of first excited state and second excited state is that ground state is n equals to 1. First excited is like when you're exciting the first energy level that it can go to, it will be n equals to 2. Second excited state will be n equals to 3. So keep this thing in mind, because question किसी भी form में दिए जा सकते हैं. So how do we solve the question? To solve this question we need to use a particular equation known as the Ritz equation. इसको erroneously बहुत लोग जानते हैं Rydberg's equation से. Rydberg's constant लगता है इसमें, but it is known as the Ritz equation. Now Ritz equation is like this. 1 upon lambda is equal to r z square 1 upon n1 square minus 1 upon n2 square. Okay, we need to use this equation. This is going to give us only 1 upon lambda, which is nothing but wave number. ये मुझे इसका result दे देगा. तो अब देखते हैं कि how do we use this result as ratio of transition energies. Now this is 1 upon lambda. If I multiply on this side by h times c, this will become equal to energy hc by lambda हो जाएगा. So I multiply this with h times c and I get this result. So I can erase off this particular part and suggest that this is the expression for energy. Okay, this becomes the expression for energy. This was the expression for 1 upon lambda times Hc becomes the expression for energy. So let's use this equation to solve our question. So E1 will be written as from n equals to 1 to n equals to 3. So first energy level to the second excited state, that is n equals to 3. So I will write it as R Z square. Z to constant है, same atom है. 1 upon 1 minus 1 upon 9. 3 square will be, so this will turn out to be R Z square times 8 by 9. R Z square times 8 by 9. The other part is from n equals to 1 to n equals to 2. So E2 will be R Z square 1 upon 1 minus 1 upon 4. Okay, which will be equal to R Z square times 3 upon 4. If I divide both of them, then this will get cancelled out. And what we would be having is 8 times 4, that is 32, and 9 times 3, that is 27. So our right answer for this question should turn out to be 32 upon 27. The right answer will be 32 upon 27. Simple question. Don't make a mistake in these calculations because this will cost you marks. Okay, so याद रखिए, इसको ऐसे ही solve करना है. ठीक है, चलिए. Next question is this. For a 1 electron atom, the set of allowed quantum numbers. 1 electron atom is like hydrogen. Like, why I'm saying 1 electron atom is like hydrogen and not hydrogen is because it could be hydrogen, it could be He plus, it could be Li2 plus, कुछ भी हो सकता है. 1 electron atom है ना. So 1 electron atom, the energy level in which it will be present, the electron would be present, is the first energy level. For that, n will be equal to 1. Principal quantum number will be 1. Now, when n is equal to 1, the L value will be equal to 0, because for the first energy level, the number of L values which are possible is only 1, and that value will be equal to 0. M value will be 0. And S value will be plus minus 1 by 2. It could be plus half, it could be minus half. Makes no difference. अगर आप ये minus half भी लिख दोगे तो भी कोई दिक्कत नहीं है. Now, one important thing that you should be aware of, that M subscript L, there is a notation M subscript L. M subscript L does not tell us about azimuthal quantum number. It talks about magnetic quantum number. ठीक है, ये L लिखा है लेकिन इसको मैग्नेटिक क्वांटम नंबर का ही एक सेकंड रिप्रेजेंटेशन बोला जाता है. सो आवर राइट आंसर फॉर दिस क्वेश्चन शुड टर्न आउट टू बी A. n equals to 1, equals to 0, m equals to 0, ms equals to 1. ms means spin quantum number. Okay, it means spin quantum number. Clear? चलिए next question पे चलते हैं. So let's look at this question. In this question, the carbon oxygen bond length in carbon monoxide, carbon dioxide and CO3 2 minus follows the order. We need to calculate the bond order. Okay, now bond order is a very simple assessment. We did the bond order assessment in class 11th, and in class 11th bond order was calculated for diatomic molecules. एक simple, बहुत ही simple idea है, a simple concept is that if the number of bonds between two atoms is 1, the bond order will be 1. Okay, for example, if I take HCl, so HCl में क्या है? There is a single bond between carbon and hydrogen and chlorine, and so the bond order over here is 1. If I take C double bond O, let's say this is formaldehyde, and there is a double bond over here, so in this region the bond order will be 2. Okay, and if I take a triple bond like N triple bond N, the bond order is 3. So if the number of bonds existing between two atoms is 1, 2, 3, then the bond order will also be 1, 2, 3 respectively. Okay, with that thing in mind, let's try to solve this question. So to solve this question, we first need to write the structure for, or the bonding, how does the molecule look like? So CO, there's a double bond between carbon and oxygen. Apart from that, there is a coordinate bond that is in this direction. Okay, ये coordinate bond रहता है because if you look at the number of electrons that is required by oxygen to form, to arrive at the octet, then oxygen needs to form 2 bonds. Carbon needs to form 4 bonds, or it means that it needs to have 4 electrons. So 2 electron तो यहाँ पे bond से आ गए इसके पास share करके, but it needs 2 more electrons, so oxygen donates it. So how do I represent the structure in much simply as C triple bond O, that be positive and negative. Don't worry about the positive and negative. There are 3 bonds that are existing between carbon and oxygen, and because of that the bond order is 3. Okay, C double bond carbon oxygen CO2. This is CO2. What is the number of bonds that you're seeing over here? You can see that there are 2 bonds, so the bond order will be 2. But in carbonate, CO3 2 minus, this is carbonate. Now carbonate has a unique feature. Carbonate can undergo resonance. The negative charge that you can see can undergo delocalization, and we can obtain a new structure which will be like this, CO minus. So it means we can have one more structure where this delocalizes. All these 3 structures are equivalent. Now, how do we calculate bond order in such a scenario? So in a molecule where resonance occurs, the bond order will be calculated using the idea that how many bonds are present and between how many atoms they are moving, as in like they are changing their positions. So there are 4 bonds between 3 neighboring oxygen atoms. So there are 3 neighboring oxygen atoms, this one, and this one. So 3 bonds हैं यहाँ, 4 bonds हैं यहाँ पे, and these 4 bonds are getting delocalized between 3 atoms. Central atom को तो हम ignore करते हैं. Okay, the method is number of bonds divided by the number of peripheral atoms between which it is delocalized. So 4 bonds, and it is delocalized between 3 oxygen atoms, so it will turn out to be 1.33. Okay, इस example को हम आगे भी extend कर सकते हैं. Let's say we take a entity like sulfate SO4 2 minus. You can see that the conjugation will take place, and this will involve the movement of this negative charge and these double bonds. You will get certain structures. If you evaluate along on the same logic, you would see that these 6 bonds are changing their positions. All total of 6 bonds are changing their position between 4 atoms. So 6 upon 4, that turns out to be 1.5. So यहाँ पे bond order हो जाएगा 1.5. So remember, this is how you calculate it. Now coming back to this question, what we can say is carbon monoxide bond order is 3, carbon dioxide bond order is 2, carbonate bond order is 1.3. Now remember that when bond order increases, bond length decreases. Okay, when bond order increases, bond length decreases. ऐसा क्यों होता है? अगर आप कार्बन कार्बन बॉन्ड को ही ले लो, then कार्बन कार्बन सिंगल बॉन्ड has bond order 1, कार्बन कार्बन डबल बॉन्ड has a bond order 2. डबल बॉन्ड बनाने के लिए atoms should have come closer. So when the bond order increases, the bond length progressively decreases. So bond order increase, bond length decreases. So bond order का सबसे ज़्यादा वैल्यू इसका है. So bond length की वैल्यू सबसे कम किसकी होगी? CO की. और carbonate has the least bond order, so the longest bond would be present in carbonate. The right answer should turn out to be A. Okay, right answer should turn out to be A. चलिए, next question is this. A metal is irradiated with a light of wavelength 660 nanometers. Given that the work function of the metal is 1 electron volts, the de Broglie wavelength of ejected electrons is close to. Now to calculate this de Broglie wavelength, I need to go through two equations. First equation is, I need to identify what is the energy of the electron when it is ejected. And how do I calculate that? We use the Einstein photoelectric effect equation, that is kinetic energy of the ejected electron is h nu minus phi, where h nu is the energy of the incident radiation and phi is the work function. So phi is the work function, energy of the incident radiation needs to be calculated. So हम कैसे निकालेंगे इसको? Energy of incident radiation is hc upon lambda and phi is given as 1 electron volts. 1 electron volt, the conversion of electron volt into joules is 1.6 times 10 raised to minus 19 joules, turns out to be equal to 1 electron volt. तो मैं 1 electron volt की जगह मैं यहाँ पे लिख देता हूँ 1.6 times 10 raised to minus 19 joules, and H is 6.626 times 10 raised to minus 34 times 3 times 10 raised to 8 upon lambda, which is 660. Clear? Now if I make an approximation and make this equal to, मैं इसको 6.6 कर देता हूँ. If I make this, if I approximate this to 6.6, then this will just get cancelled off and we would get 6, and this is in terms of nanometers, so इसको मैं 10 raised to minus 9 लिखूंगा, and so this will become minus 1.6 times 10 raised to minus 19 joules. This will become somewhere about 3 times 10 raised to minus 19 minus 1.6 times 10 raised to minus 19 joules. Okay, finally we would get an answer 1.4 times 10 raised to minus 19 joules is the kinetic energy of the ejected electron. Okay, is the kinetic energy of the ejected electron. Okay, so having said that, the kinetic energy will turn out to be 1.4 times 10 raised to minus 19 joules. Now to calculate de Broglie wavelength, lambda, we use this expression lambda by h by p, lambda equals to h upon p. P is the momentum, h is the Planck's constant. And how is momentum related to kinetic energy, which is 2 m ke. Okay, 2 m ke. So I will write the value of h turns out to be 6.626 times 10 raised to minus 34 divided by root over 2. What is the mass of an electron which is ejected? 9.1 times 10 raised to minus 31 kgs, and kinetic energy is 1.4 times 10 raised to minus 19 joules. Okay, if you calculate this, you will get the answer. This is minus 34, so 31, 19, this turns out to be 50. 31 and 19 turns out to be 50. So if I take the root of it, that will turn out to be 25. So minus 25 यहाँ पे है 24, तो 25 and 9. So somewhere about ये होना चाहिए आंसर. यूनिट्स देख के मैंने 10 to the power के वैल्यूज देख के निकाल दिए. 10 raised to minus 34 and this will turn out to be 10 raised to 25. So 10 raised to minus 34 minus plus 25 will turn out to be 10 raised to minus 9. Right answer should turn out to be C. Okay, take some approximation and get the answer. Clear? Chalo, let's move ahead. Next question is this: the spin only magnetic moment of ZCl4 2 minus is 3.87 Bohr magneton. BM is Bohr magneton. ये magnetic moment calculate करने का एक unit होता है. where Z is, which element or which metal is Z. How to solve this question? What we do is we first calculate what is the oxidation state on Z. So the oxidation state on Z is, let's say, X, and oxidation state on chlorine is -4, which is equal to -2. So X turns out to be +2. X turns out to be +2. If X is +2, then which of these elements have this value of magnetic moment? Now the magnetic moment's value, which is 3, mu is magnetic moment, which is equal to root over n times n plus 2. N represents the number of unpaired electrons. So if the value of mu turns out to be 3.8, तो हम बोल देते हैं कि 3.87 का मतलब ये लगभग 4 के बराबर है, almost 4 but not equal to 4. So if this is not exactly equal to, mu is not exactly equal to 4, it's slightly less than 4, then this value, what number should I place over here? So this value will be very close to 4 but not equal to 4. The n value should be equal to, in that case, for mu equals to 30. If mu is 3.87, n value will be equal to 3. If I put 3 over here, I will get 3 times 5, that will be 15. Root 15 will be 3.87. If I get this result, I just need to identify that in all of these dye positive ions, अगर इनके मैंने dye positive ions लिए, then if I take these dye positive ions, in which case I have 3 unpaired electrons. So Mn is 3d5 4s1, sorry, 3d5 4s2. Nickel is iron, cobalt, nickel, so 3d8 4s2. Cobalt is 3d7 4s2, and copper is 3d10 4s1. If I write the configuration of the dye positive cations, so Mn2 plus will be 3d5, where number of unpaired electrons will be equal to 5. 3d5 4s0. Nickel 2 plus will be 3d8. If it is 3d8, so if you remember d orbitals इस तरह के 5 compartments, 1 2 3 4 5 6 7 8. Okay, so 3d8 4s0, the number of unpaired electrons will be 2. CO2 plus, it will be 3d7 4s0, number of unpaired electrons is 3, and copper 2 plus, it will be 3d9 4s0. So the number of unpaired electrons will be 1. How many unpaired electrons do we need? We need 3 unpaired electrons, and the right answer for that turns out to be cobalt. So the answer for this Z should be cobalt, for this value to be the magnetic moment of ZCl4 2-. ठीक है, चलिए. Next question is this: among the following metals, the strongest reducing agent is? This question is very simple. If you look at these metals, among these metals, one metal lies below hydrogen in the activity series, and वो आपको मालूम है क्योंकि electrochemistry पे हमने session कर लिया है. The arrangement of the other elements will be like this. Which element lies below hydrogen in the activity series? It is copper. Okay, and if I look at iron, zinc, nickel, the arrangement is zinc followed by Fe followed by Ni, and then comes hydrogen और फिर copper आता है. Okay, now the point is strongest reducing agent. This series tells me about the tendency of zinc to convert into zinc 2 plus. Okay, Fe to convert into Fe2 plus. ये activity series है. Activity series में हम क्या करते हैं? We place highly reactive metals at the top and most unreactive metals at the bottom because we want to displace a metal from its salt which is present in the bottom region by using a reducing agent which is a metal at the top. Okay, तो activity series में जो ऊपर में जो metals present है, they will displace any metal which is from its salt which is present down in the series. Now it is important to know that कि जो ऊपर में present है, if it is displacing something, it is reducing it. So the tendency of zinc to convert into zinc 2 plus will also tell us the tendency for it to give electrons, क्योंकि ये बाहर 2 इलेक्ट्रॉन दे रहा है. It is giving out 2 electrons. If it is giving out 2 electrons, then the tendency of zinc to convert into zinc 2 plus will also be the tendency of zinc to give 2 electrons to something. Okay, when it is giving electrons, it is acting as a reducing agent. So the right answer to this question will be zinc. Clear? The right answer to this question will be zinc. Next question. For a 4p orbital, the number of radial and angular nodes respectively is. To calculate this question, there are two ways. Either you know what a 4p orbital looks like and you know how its radial and angular nodes are present, or what you do is you use a formula. Okay, examination में आपसे आप वो कीजिए जो कि आपके लिए easy है. If I want to calculate the number of radial and angular nodes, the method of calculating radial nodes Rn, I'm writing Rn as the notation for radial nodes. It is n minus L minus 1. Angular nodes is L, and total number of nodes is equal to n minus 1. Very simple formula. Examination में इसको use कीजिए so as to get the answer more quickly. So n value is 4, n value is 4, L value for P is 1, this turns out to be 2, and for P L value is 1, so radial nodes is 2, angular nodes is 1. If you want to calculate this in the diagrammatic manner, that will take a bit of time because उसके लिए आपको orbitals का shapes and radial nodes and angular nodes का location आपको जानना चाहिए. I'll tell you how it is done. So it is also a very simple method. So if I want to look at a 2p orbital, let's say 4p orbital, मैं 2p orbital को देखना चाहता हूँ, then I take a 3-axis system. ये 3 axis मैंने ले लिए. This is X, this is Y, and this is, let's say, Z. 2p orbital, or let's say 2px orbital will be present like this. 2px orbital will be present over here. This is plus Y, this is minus Y. This will be what a 2p orbital will look like. Okay, a 3p orbital will look slightly different, but इस तरह का दिखेगा वो. This is what a 3p orbital will look like. It looks as if it is enclosing a 2p orbital. Okay, a 4p orbital will look like this. This is what a 4px orbital. So this is what a 2px orbital looks like. This is what a 3px looks like. This is what a 4px looks like. Now if I look at these three representations for the 3 orbitals, can I find a plane which passes through the orbitals but does not bisect any of the lobes? कोई ऐसा plane हम बता सकते हैं which passes through the origin and does not bisect any of the lobes? हम planes ऐसे ले सकते हैं, but they will bisect it except for one plane which is the YZ plane. So YZ plane if I take YZ plane will pass through the origin but not bisect the orbital. So a plane which, what is this plane telling us? Lobes are regions of electron density. If there is no electron density on the plane, it represents a nodal surface or the location of a angular node. सभी के लिए वो plane common रहेगा. YZ plane will be the common for all these orbitals, and so it will turn out to be a angular node. It will be the nodal plane for all of them. What अब ये हो गया angular node का. So एक plane रहेगा that will be common for all of them, and so our angular node will be 1. How the radial node is 2? So look at the boundary. So if I have to reach to 4p, this is the boundary of 4p. The blue one is the boundary for 4p. If I have to reach the boundary for 4p starting from the origin, how many intermediate surfaces do I have to cross? जो lobes के surfaces हैं उसको कितने को cross करना पड़ रहा है? I have to cross this one, I have to cross this one so as to reach to this point, isn't it? I have to cross this one, I have to cross this one so as to reach to this point. So how many surfaces am I crossing? I'm crossing 2 surfaces moving along the radial path. So this gives us the number of radial nodes as equal to 2. Okay, radial nodes are located at the boundary surfaces. So there are 2 radial nodes. The right answer will be 2. So either you do it diagrammatically or you do it I'd say mathematically, वो आपके ऊपर depend करता है. ठीक है? Next is the oxidizing ability of the given anions is in the order. How to identify this? This is a very simple question, very easy question. सबसे पहला काम ये कीजिए कि सबका oxidation state calculate कीजिए. So if I calculate the oxidation state of titanium, oxidation state of titanium is 4 plus 4, vanadium plus 5, chromium plus 6, manganese plus 7. Very easy question. आपको सिर्फ oxidation state calculate करना है. When you calculate the oxidation state, you can see that the oxidation state for manganese is highest and titanium is lowest. The tendency for manganese to take up electrons will be higher because उसके ऊपर oxidation state सबसे ज़्यादा बना हुआ. Means positive oxidation state is maximum oxygen manganese. So if the oxidation state increases, the tendency to act as an oxidizing agent will also increase. So plus 7 will be the strongest oxidizing agent, plus 4 will be the weakest oxidizing agent. The right answer should turn out to be A. Okay, एक बार में answer आ जाएगा. Right answer will turn out to be A. Next question is this: the allowed set of quantum numbers for an electron in hydrogen atom. Okay, allowed set of quantum numbers. So what are the allowed set of quantum numbers? See, if n is 4, you might ask that, sir, hydrogen atom में n equals to 4 कैसे हो सकता है? The electron can get excited to that level. Okay, only then it can have these as the quantum numbers. Other than that, it will always be present in the ground state. So एक excited state में present एक electron के लिए quantum numbers क्या होगा? n equals to 4, l equals to 2, m equals to 0, ms equals to 0. Now ms cannot be 0. ms always has to be plus half or minus half. So ये तो हो नहीं सकता है. Okay, next, plus half, minus half, plus half. This is all right. Let's look at n equals to 3, l equals to 1, m equals to minus 3. See, remember, when l equals to 1, then the maximum value of magnetic quantum number. So if L value is, let's say, 1, the maximum value of magnetic quantum number, or the values, will range from minus 1, 0 to plus 1. So over here L is 1 but M is minus 3. This doesn't look right. Okay, next, 3, 3. Now when N is 3, the maximum value that L can take up is N minus 1. Okay, so if n is 3, the values that L can take up, azimuthal quantum number can take up, is 0, 1, 2. These are the values that it can take up. It will take up 3 values one of which will be 0, 1, 2. Okay, so ये भी नहीं होगा, एक ही बच जाता है. n equals to 2, L equals to 1. Maximum value can be taken, the number of L values that can be taken is 2. One value will be 0, the other value will be 1. So 2, 1, ml. If L is 1, magnetic quantum number can take the values from -1 to +1. So -1, S is half. This is right. This is absolutely correct. Clear? So allowed set of quantum numbers, the right answer should be D. Perfect. Let's move ahead. The set of principal azimuthal magnetic quantum numbers that is not allowed for hydrogen like atom. So take this as a homework question. Please do comment about this question in the comment section. बहुत सिंपल सवाल है, इसके ऊपर हमने 2 क्वेश्चन कर ही लिए हैं. Try to tell me what is the which set of quantum numbers is not allowed. Comment in the comment section. I'll reply to you guys. Okay? चलिए. Next question is this. The plot of kinetic energy half mv square of ejected electrons is plotted versus frequency of incident radiation for 4 alkali metals. The alkali metals M1, M2, M3, M4 are respectively. How do we solve this question? Question is not very difficult, slightly tricky. कैसे solve करना है इसको देखिए. So what we can see over here is kinetic energy is plotted versus frequency. Okay, this is frequency. This is for metal M1, this is metal M2, this is metal M3, metal M4. Okay, so this is kinetic energy plotted versus frequency. Now when I try to plot kinetic energy versus frequency, kinetic energy versus frequency of incident radiation using Einstein photoelectric effect equation. So this is the equation that I need to use. Now you can see that this is on the y-axis and this thing is on the x-axis. Okay, the slope is uniform for all of them. The slope is nothing but the Planck's constant. What is the intercept? Intercept is the work function. Okay, intercept is the work function. So if I try to plot this, I should get a plot like this. कुछ यहाँ पे जाके ये कट करेगा. So this is kinetic energy versus nu. Okay, the intercept will be the work function, which is phi. Pakka? Now let's look at a simple idea. If I look at the values of kinetic energy at this point, the value of kinetic energy is 0. Okay, at this point value of kinetic energy is 0. So at this point, okay, just when it starts to getting ejected, so kinetic energy is 0, which is equal to h nu minus phi. So when kinetic energy is 0, h nu is equal to phi. It means if the work function is more, then the frequency of the incident radiation should also be more. It means if phi is more, frequency of incident radiation should also be more. That means if the tendency to leave the electrons is less, then I need to provide more energy so that it leaves the electron, or I can remove the electron. Okay, work function क्या होता है? Work function is the tendency of the element to hold the electrons. If the work function is less, you can remove electrons easily. If the work function is high, tendency to remove electrons is less. Okay, tendency to remove electrons is less. So if the work function is high, you need to give more energy. You need to use a electromagnetic radiation of higher frequency to remove the electron. With that being settled, if I look at this, so for metal M1, I am using least frequency. And for metal, so for M1, frequency used is least. Can I see this? Least frequency use kiya gaya. And for metal M4, I'm using frequency which is largest. Okay. Now, simple idea hai, we have taken alkali metals. As you look at the size of alkali metals, lithium is smallest, sodium is slightly bigger, potassium is even slightly bigger, and so on and so forth. The size increases downwards. If I look at the force that the outermost electron perceives due to the nucleus, then the force will decrease as we go down the group, and so the tendency to remove the electrons will increase. And that is what you know from the concept of ionization energy, that the tendency to remove electrons as we go down the group increases. So ionization energy decreases. So the energy required to remove the electron will decrease. So this M1, the alkali metals M1, so M1 requires least amount of energy for us to remove the electron. So M1 should be what? The one which is largest atom. So M1 should be rubidium and M4 should be lithium. Rubidium, potassium, sodium, lithium, the right answer should be B. ठीक है? Perfect. सिंपल से सवाल है, एक बार फिर से इसको रिवीजन कर लीजिएगा. This is a very easy question. Okay, so with this we come to the end of today's session. You have seen that we have not encountered any question from periodic properties except for oxidizing behavior and reducing behavior. So in SX section, periodic properties से question बहुत कम आते हैं. Primarily questions come from atomic structure, and of these three sections that we were supposed to discuss today, primarily questions come from atomic structure and bonding. से questions आते हैं, and the questions in bonding are from primarily bond order. Okay. Also, I'd like to tell you that we would be conducting KVPY test series in which there will be 2-part tests, 3 full tests, and there will complete analysis, and that's at a lightning price of 1,000 rupees. Please do tell your friends about this. Please do join the Telegram group. And the last but not the least, please do like, share and subscribe the channel, and please do comment about any queries that you have or any questions that you have in the comment section. Okay. So this is Saurav Goswami signing off, and I wish all of you a wonderful day ahead. Bye bye guys.